Now, as h approaches 0, as we basically reduce the number of weekly hours that you work, what's happening? Well, the hourly wage is rising. And so in order to get closer to 0, we would have to really zoom up because it looks like the hourly wage is already at $100 for however many hours this is. In fact, if we go over to our table, we can kind of see that as the number of weekly hours that you work is less and less and less, but you're getting paid the same annual salary, it looks like you're making a lot of money. If you only work 1 hour a week and you're being paid $56,000 a year, then you're actually getting paid $1,076.90 per hour. Because the hourly wage depends on how many hours you work. So, well, theoretically what's happening here? Well, as we, in theory, would get closer to 0, I'm going to up this to, let's say, $5,000. In theory, now it's kind of hard to see here. Let me set my number of hours from 0 to 1 just so we can kind of get a better image. If I set my hours 0 to 1, you can see that way up here, that's a max of $5,000 an hour. So if I'm working, let's see about how many hours that is. That's less than half an hour a week. Again, this is very theoretical because nobody actually works this, right? But if I work a fifth of an hour, I actually get paid around $5,000 an hour. Now that'd be great, wouldn't it? Just work less than an hour a week, and you get you're worth about $5,000 an hour. So what we would typically say is that as the number of hours approaches 0, in theory, this continues to jump up. Your hourly wage, W, approaches infinity. So let's conceptualize that a little bit more. So as we go this way, the output goes down, but as we travel this way, the output goes up. And that's basically what we're demonstrating here with this notation. As the hours approaches infinity, the wage approaches 0. As your hours approach 0, your hourly wage approaches infinity. Now we notice over here that if we go back to our table, if you work 0 hours, there's an error. Well, why is that? Let's think about our equation, which is W equals 56,000 over 52 times H. Well, if I put in 0 for H, then I get 56,000 over 52 times 0. And 52 times 0 is 0, so I have 56,000 divided by 0. Well, wait a minute. How many times does 0 go into 56,000? And don't say 0 because I can take zeros out of $56,000 infinitely many times and still have plenty of money left, right? I can give everybody in the world $0 out of my $56,000 salary, but I will never deplete it. So we would say that the 0 goes into 56,000 an undefined number of times. It just doesn't make sense. So if we were to really look at our graph, which I'm going to draw this out again. So I'm going to draw arrows to indicate that it continues going up and it continues going over to the side, but you'll notice that it never actually, in theory, reaches these axes. So I'm going to come over here and I'm going to say, all right, well, because this value of 0 hours, this is H equals 0 hours, is undefined, I am going to put a dotted line here as an imaginary dotted line to say that this line will continue to approach this dotted line, but will never reach it. Similarly, if I continue to work infinitely many hours, then in theory, my wage will get closer to 0, but it'll never approach it, right? Because as long as I'm making an annual salary, even if I work 1,000,000 hours a week, if that were possible, I would still, in theory, never hit $0. So these are what we call, and this would be your wage equals 0, it would be the horizontal line, or y equals 0 if you think that way, and this would be the line x equals 0 if you think that way. These are what we call asymptotes. Asymptotes. It's kind of hard to say, but basically these are theoretical lines that represent what happens as the input, I'll just call it x, approaches infinity, or as x